Let's take a little time to reveal the prehistoric stories that the earth once concealed. Mix them all together on this ancient land. It's time to spread some Palaeo Jam. Hello, welcome to another edition of Palaeo Jam. I'm your host, Michael Mills, and in this episode we have Dr. Ellen Mather, Adjunct Associate Lecturer at Flinders University, back in the room, or in the Zoom in this case, and we had Ellen in season 1 talking about an Australian vulture, and we might talk a little bit about that during the course of the next 30 minutes, but we're also going to be talking about eagles. Welcome, Ellen.
Thanks for having me. Great to be back.
Yeah, great to have you. And so when we last spoke, you had looked at this bird that had thought to have been, it was thought that it had been an extinct eagle, and you reclassified it. You had a look at it and you've gone, actually.
That's correct. So it had actually been suggested previously that it could be a vulture by paleontologists such as Gerald Van Tetz and Patricia Vickers-Rich, but it wasn't actually confirmed until my research on it.
Yeah, so what was it? For those that haven't heard that episode, and I recommend listening to it because we also talk about flamingos in Australia, flamingos and vultures in Australia, like who knew? But what was it that confirmed to you with cryptogyps? Is that how I say it?
Yep. That's the one.
What was it that made you go, yeah, I can confirm this was a vulture?
So it was closer comparisons of the type specimen, which was a distal humerus, to a range of species of eagles and vultures, as well as new fossil material we had from a few sites that we could refer to cryptogyps. So one of the big ones was a tarsal metatarsus. So that's one of the lower leg bones in the bird that connects directly to the foot. And so this bone is quite important as it can tell us a lot about, what a bird is doing with its feet. So naturally in eagles, there's a lot of adaptations for musculature to increase grasping strength for grabbing onto prey. But vultures don't have this. So they actually have fairly weak musculature compared to other eagles because they're not doing that. They're scavenging, so they're mostly just using their feet to walk around. And so this tarsal metatarsus was much more similar to a vulture than an eagle, and it really helped reclassify the species.
And it's fascinating, something like that, isn't it? That comparing it with things that are already known, and particularly in terms of the functional use of that, it's like, well, this can't be that. It has to be this.
Yeah, that's right. So in some ways, study of more recently extinct animals is a bit easier than those that lived in the very distant past because we often have a lot of comparative species that are around today. So not in all cases, like I'm sure some of these researchers of the marsupial mega-fauna can tell you we had some very odd animals that don't really have many modern comparatives, but they still have, vultures and eagles alive today, so we can get a good idea of what extinct species of those birds would have lived and been like.
Yeah, we can go and look at a living vulture and see how it operates and exists and functions and what the particular specific, I guess, structures it has in its skeleton and other things. What we can see what it does and how it works.
Yeah.
Yeah. So, okay. So let's get to move on from eagles, although we might come back to vultures. So this new research, there was already one, and again, I'm going to check the pronunciation with you. I keep wanting to say Dinotweetus.
Okay, that's actually a fun way of saying it. Dinatoatus.
Right, so not Dinotweetus then.
No. You're welcome to call it that if you want.
Well, it gives a kind of a sense of what it like dino, like big and tweetus. Yes, it's a bird. Maybe you can use that for another name for another thing. You're welcome.
Maybe, yeah.
Just make sure my name's on the paper if you do. Okay, so Dinotoaetus.
Donatoatus.
Donatoaetus. Okay. So there was already one within the group that had been described.
That's correct.
Is that right? Gaffe, the
Yeah, so Donatoatus gaffi, which is the largest eagle to have ever lived in Australia. So we reckon it probably would have been up to twice the size in body mass that compared to a modern wedge-tailed eagle. So pretty large.
that's a very, very large eagle. For those of
Mm.
us that live in Australia and have the privilege, particularly driving up through the outback, and I spend a bit of time up in the Flinders Ranges and stuff, and the best part of or one of the first, I suppose, signals and indications that you're kind of getting there is when you start seeing wedgies flying around or sitting on the road waiting for kangaroos to be run over.
Mm.
So twice the size. The new one you've described is not quite as big as that, but it's interesting that you've got two now within that group.
Yeah, it is. So it really wasn't expected on our end. So usually you have what is called competitive exclusion or niche partitioning. So you can't have too many species of the same kind, using the same resources in the same place at once. So usually that's so that tells us that for multiple eagles in this group to be around at the same time, they had to be exploiting different niches or perhaps inhabiting slightly different environments to be able to coexist.
Yeah. So what do we know? What do we know? What the two? Well, with the wedge-tailed eagles, which would have been around at the time, I guess. So you've
Yes.
got three major eagles plus a few other things and giant ground birds and vultures. And it almost reminds me of part of Tim Flannery's The Future Eaters when he's talking about New Zealand as being an island of birds. We forget sometimes the degree to which birds in Australia seem to be central to our, I guess, evolutionary story.
Yeah,
Um,
that's right.
I mean, like, because songbirds came from here too, I think.
Yeah, so passerines, so the songbirds originated within Australia.
Yeah. So bringing us back to this new research, like if we saw one today, what would we be looking at? What would it look like? What do we know? And obviously, with a few bones, you can't say what color necessarily it was and stuff. But what do you reckon it looked like?
So our new eagle in the genus Dinatoatus, the species is Dinatoatus pachyosseus. So that literally means the thick-boned, powerful eagle, and the name literally named for its very robust bones. So size-wise, it was closer to a wedge-tailed eagle than its larger relative Dinatoatus gappi, but it would have been a much more heavily built eagles compared to a wedge tail, so probably a bit more chunky, more muscular, perhaps.
Yeah, I was thinking like I was thinking chunky because it immediately put me to mind of Euros,
Mm.
Macropodus robustus. So again, going back to the Flinders, you go up there and they kind of live somewhere between the flatlands where the reds and greys live and the hills where the yellow-footed wallabies live. They kind of live in that twilight zone between the two, but they're chunky.
Mm.
They're strong and powerful. So these are kind of chunky, as if a wedge-tailed eagle is not powerful enough, but a chunky wedge-tailed eagle. Is that what we're looking at?
Basically, yeah. There also is some indication of different flight behavior based on the wing bones. So for Dinatoatus pachyosseus, we have a complete humerus, so that's the main bone in the upper arm that connects directly to your shoulder. And compared to a wedge tail, the shaft has much more notable curvature. And a wedge-tailed eagle has a very straight humerus shaft. And what this tells us is that Dynartoitus pachyostes was engaging in more flapping flight. So eagles with much straighter humeri tend to be more soaring birds rather than flapping birds. So that could indicate perhaps preferred ecology. So it could be that Dynartoitus pachyostes preferred more environments where it wasn't able to soar around as freely. So forests might be an example of that, because it has to, constantly dodge through the trees. Or it could be an indication of, behavior. So perhaps it was more of a pursuit predator, directly flying after prey rather than necessarily waiting to ambush it.
Because yeah, wedgies often just float. I've actually saw last year because the rains had been good and things were good. I was like 15 in a group soaring. So
Mm,
these ones, um, Pachyostes, didn't do that, or
yeah,
I don't think they did.
well,
And it's
maybe
remarkable.
not to the same degree.
Yeah, it's quite remarkable though, isn't it? Just on that bone, that single bone can give us an indication that, well, actually, this is something that may well have flapped in and around like through forests, through dodging forest, because it didn't do the soaring thing. And it gives you
Mm,
that sense of the different ecological niches that you were talking about.
yeah.
Yeah, it's fascinating stuff. So where were these bones, where were these fossils found?
So currently we just have fossils of Pachyostes from the Naracoorte caves. We have fossils of Dynartoitus gaffy from Naracoorte caves, Mares Cave up in the Flinders Ranges, as well as the Wellington Caves in New South Wales. And Cryptogyps is probably the most broadly expansive, because we have fossils from Western Australia, from the Nullarbor. We have fossils from the Lime Coast region, so near Mount Gambier, up in the northern part of South Australia by the Warburton River, and also from the Wellington Caves in New South Wales. So it was present across most of the southern half of Australia at the least.
Okay, so yeah, is there a and obviously finding fossils is a function of taphonomy, which can be it's just, well, we just happen to have found these fossils in these particular areas. These
Hmm.
birds may have been elsewhere. We just haven't had the fossils, or the fossils they didn't fossilize in those areas. But
Yeah.
where we have found them, what is there a similarity in what the living ecosystems might have been like across those places?
A little hard to tell with some. So a lot of the fossils we have from the Wellington Caves example, they were collected a very long time ago and they didn't have their exact location data or stratigraphic data written down, so we don't know exactly which deposits they came from and therefore what the context of those fossils is. So we don't know what species they might have lived alongside. The Mayor's Cave one is a bit similar because there's not as much burial in that cave. They were rather more scattered along the cave floor. We do know that we can give it a rough age to late Pleistocene, because there's also mega-fauna species such as Phylacoleo known from that cave. Also, funnily enough, fossils of koala from that cave. Apparently, according to Aaron Kamens, that's the first record of koalas from the southern Flinders Ranges. So that could perhaps be indicating a more forested environment compared to the quite arid, open scrubland we see around there today.
Yeah, because we're often told it's interesting the koala thing, because we're often just like, well, the koalas that are in the Adelaide Hills aren't from here. The koalas on Kangaroo Island aren't from here. But maybe there were koalas here, but a long, long time ago.
Yeah.
But in fact, not maybe. If there's a fossilized koala in the Flinders Ranges, then there were, I guess.
Mm.
So the where you've got two different kinds of this group, Gaffé and Pachyostes. So that suggests that maybe they had a common ancestor, and maybe this group came from here. Is that what the researchers what you're thinking with this?
Yeah, so obviously for two species in the same genus to exist, they had to have had a common ancestor in the past, and the nature of evolution means that that common ancestor could have lived potentially up to millions of years ago. So because we currently only have species of Dynatolatus in Australia. That likely means that ancestor arrived in Australia and over time diversified into multiple species. So it's quite likely that the Dynatolatus genus was present in Australia for quite some time before the last few species went extinct in the late Pleistocene.
Yeah. Okay. So we don't find them anywhere else in the world, this particular group?
Yeah,
Yep.
so far.
Okay. Okay. Again, that could be because that's what it is, or it could be we just haven't found them yet. Okay.
Yeah.
Um, so we in Australia there's often conversations about the extinction of the megafauna, and you mentioned, finding some of these in Narragansett caves and that they would have lived alongside thylacoleos, maybe hunted particular well, obviously they would have eaten things that were alive back then, and
Yeah.
maybe diprotodon joeys were delicious. I don't know. But what does it tell us about the extinction event in Australia? And I use the word event kind of loosely. Does it help inform us about how it might have happened here, or why?
Um, well, having, certain birds of prey go extinct does show that there were more, I suppose, widespread consequences of the mega-fauna extinction. So other species that were likely relying on them would have, so it's sort of like a cascade effect. So other species that might have relied on them also subsequently went extinct as well. So that might be because they were, so like in the case of cryptogyps, having the vast majority of your large-bodied animals dying out would have been pretty serious, because those animals would have been a main source of food for them. And it might be that other species moving in to fill those gaps. So like all the kangaroos that we have today, maybe they weren't quite as numerous as they are in the present. So they might have not have been quite enough to so essentially fill in that gap for them.
Yeah. Because I'm just thinking, like following on from that, at the size that these birds were, and their chunkiness, what would they have eaten? Because, and I ask this question because a couple of years ago I was up in the Flinders Ranges, and we were looking for yellow-footed rock wallabies, and from a distance we saw two wedge-tailed eagles dive bombing a euro. Now, it wasn't a fully grown euro, but they were dive bombing it, and we eventually got to where the dive bombing had happened, and they'd literally knocked it off a cliff. So, and I'm not saying that these chunkier ones are going to be like chasing diprotodons, fully grown diprotodons, but what can we? And I suppose, because the other interesting thing too is that idea that they're dining on different things. So what would they each have for lunch?
So certainly the Dynatolatus species, their size and fairly robust build does indicate they would have been well adapted to preying on relatively large mammals and birds. So, and these probably would have been quite large compared to their own body size. So again, quite a few kangaroos probably would have been on the menu, and quite likely perhaps juveniles of megafaunal species. So obviously they're not going to be pursuing an adult diprotodon, because that's a bit out of their size class, but a diprotodon joey that's wandered too far from its mum, or even joeys of the giant kangaroos that were around the time, or maybe even some of the giant flightless birds certainly could have been an option. And of course that's not taken into consideration nearly grown or grown individuals that might have been incapacitated in some way, whether through sickness or injury.
So they ate koalas then?
That's certainly a possibility. So we do have large eagles today that prey on arboreal mammals. So most famously, there's the harpy eagle in South America that preys on sloths. So it actively flies past, grabs a sloth and pulls it out of the tree. So Dynatolatus, especially Dynatolatus gaffy, certainly could have been large enough to do that to a koala.
That's quite, it's just the visual. I want people that are listening to visualize this bird flying down, plucking it. It's like grabbing an apple from a tree, isn't it? And then just scoffing it down. Okay, so Australia, this giant continent with this fascinating story of bird evolution. Where does this and the discoveries that you've the vulture that we talked about, where does that put us and the songbirds and stuff? Where does it put us in terms of importance to understanding bird evolution at an international, at a global level?
So, in both cases, eagles and vultures are likely to have originated outside of Australia. I think currently, based on the oldest fossils, eagles are thought to have originated in the northern hemisphere. I think vultures quite likely did as well. So vultures actually appeared during the Miocene, around the time when grasslands were expanding and animals were, getting large grazing animals appearing. So it's significant in that it shows that, today, of course, Australia has no vultures, which makes it a bit of an anomaly compared to most other continents except Antarctica. And of course, Antarctica, there's a very good reason why we don't have vultures there. But Cryptogyps shows that vultures did in fact reach Australia, which really should be no surprise because we know they made it as far as Southeast Asia. And so the fact is that for whatever reason, Australia is really the only continent to have completely lost its native vulture species. So whether that's because the severity of our mega-faunal extinction was just really hard compared to elsewhere, we don't really know, but it's very striking to say the least.
It is, yeah, it is. So, and speaking of the cryptogyps, my understanding too is that as you've been doing this research, you've learned some new things about that. Is that right? In terms of
Yeah, that's right. So we got some fossils from a site called Green Waterhole Cave in South Australia. It's near Mount Gambier, so very close to the Naracoorte region. And it's a flooded cave, so all the bones are actually underwater. So we actually found, so in the past couple of decades, a pair of almost complete wings has been found. So most of the bones from the wings, unfortunately not in a complete humerus because that would have been useful, but you take what you can get. Mm-hmm. And what they show is that cryptogyps lacked what we call pneumatization of the wing bones. So in a lot of vultures, they have these regions in the wing bones that are filled with like these sort of holes and air pockets. So this is thought to be an adaptation to help lighten the load essentially, and which is pretty important when you're a large soaring bird. But Cryptogyps doesn't seem to have had them. So perhaps compared to living vultures at least, it might have been a slightly less efficient soarer, but clearly it had no trouble getting around given that it's present in so many sites across southern Australia. So it's interesting to say the least. So it might actually reflect perhaps that it's a more, we say basal or primitive vulture. So perhaps it comes from a lineage that's that's older than most living vultures. So it might have been from a group that predates that specialization, perhaps. So its ancestors didn't develop that trait, but it managed to survive anyway.
Right. So do we have any sense of the overseas vultures, of their ancestors and similarities between Cryptogyps and them in terms of that I guess that not as well evolved soaring ability?
So it's generally pretty much present across all vulture subfamilies and families, because again, you get these quite large birds who, because you want to be large to have a large wingspan because that makes soaring more efficient, but at the same time you don't want to get too heavy because that's just going to make things more difficult for you. So cryptogyps comparatively was slightly smaller than a wedge-tailed eagle. So compared to quite a few vulture species, that's actually on the smaller side, strange as that sounds. So it might be perhaps that as a smaller vulture, cryptogyps wasn't quite as heavy, so it didn't need that sort of adaptation. There are some very small vultures out there that would have been about half the size. So I think some of them might have that pneumaticization, but perhaps they come from an ancestor that it did have it, but they gradually grew smaller over time. So it's something that's really interesting, to say the least.
Yeah, and it is, isn't it? All of the whenever there's a change, whenever there's because the way that evolution works is that the things are functionally dictated. I guess it's like well, this works, but you're also building on what was already there in the first place.
Yeah.
Talk to a giraffe and its stupid neck and things and stuff. Okay, we've got about 3 minutes left. So what next in terms of, season 1 we talked about vultures, season 2 it's eagles and vultures. What are we going to get in season 3 of Palaeo Jam? Are you working on?
I'm currently working on a small project that's looking at these old species that were described from the Darling Downs in Queensland, and currently there's some debate as to their validity. So they were described as extinct species, but currently there's a bit of a debate as to whether they're actually extinct species or if they've just been misidentified as specimens of living species, and that's something that's not unheard of. So sometimes back in the day, especially when researchers might not have had the same access to resources or collections that they do today, they might have just drawn some premature conclusions about the uniqueness of their specimens and decided, okay, this is a distinct species, but maybe it's not after all.
Yeah, so you bring a fresh set of eyes to something that's been looked at. It's not about going out into the field and digging up new things in this particular case. It's about looking in the drawer at what some other folk have looked at already, I guess, and going, well, actually, maybe it's this or maybe it's something else. And
yeah, that's pretty much right.
And I guess too, we given the nature of technological innovation, there's a whole bunch of techniques in paleontology that can be used now that we couldn't use 20 years ago because they didn't exist, or 30 years ago, or 100 years ago.
Yeah, that's absolutely right.
So, what is it about birds? You've got a minute to tell me. What is it about birds that for you have gone, that's the one, and eagles and vultures in particular? Because it's always interesting because paleos do tend to find a little thing that they love working on and stuff. So what was it for you about these cool little winged things?
Birds are very interesting because they're a very diverse group. They're the only surviving descendants of the dinosaurs, of course.
It's because they're dinosaurs, isn't it?
That's part of it, I suppose.
That's part of it.
But yeah, so it's just incredible how many niches they occupy and just how diverse a group they really are.
Yeah, I think that is the correct answer. 11,000 species of birds?
Something like that, yeah.
On the planet, and it's like, yes. I think we are in the last 8 or 9 seconds. Thank you so much, Dr. Ellen, for joining us again. And we look forward to hearing from you again as you continue your research career.
Thank you.
It's time to spread some Paleo Jam.